Hello students, we were doing differential equation. Today we will start next type of differential equation, that is linear differential equation. Linear differential equation. Linear differential equation, what do you mean by linear? Linear means the equation or the polynomial which has degree 1, and differential equation means the equation in which we have any term of derivative. So dy upon dx plus y is equals to sin x. Say the equation in which dependent variable y, because y depends on x, derivative of y with respect to x, the equation in which dependent variable y and its derivative has degree 1, or we can say that of first degree, is called linear differential equation. A differential equation is linear if the dependent variable y and its derivative has degree 1, then it is called linear differential equation. Linear differential equation is of the form dy upon dx plus p into y is equals to q. Let us start with the questions. Question number 1. Write down the statement. Solve the differential equation dy upon dx minus y upon x, dy upon dx minus y upon x is equals to 2x square. Now this is of the form dy upon dx plus py is equals to q. P here is minus 1 by x and q is 2x square. Equate this equation by this, we get this. Now first we have to find integrating factor. E is equals to p dx. This is formula for finding the integrating factor. What is p? Minus 1 upon x dx. Integral of 1 upon x is log of x. E minus log x, or we can write it as e log of x minus 1. E and log will get cancelled. We get 1 upon x. After finding the integrating factor, the solution of this equation will be y into integrating factor is equals to integral of q into integrating factor dx plus c. What is integrating factor? 1 upon x, so y upon x. Q is 2x square, multiply 1 upon x, integrating factor. 1x will get cancelled. Integral of x by using the formula x power n plus 1 upon n plus 1. So 1 plus 1 is 2 plus c. So we get y is equals to x cube plus cx. Y is equals to x cube plus cx. Note it down. Now the next one is question number 2. Solve the differential equation dy upon dx plus y upon 2x is equals to 3x square. Now y is equals to 1, p is equals to 1 upon 2x, q is equals to 3x square. First we have to find the integrating factor. Integrating factor is equals to e integral of p it as log of x power 1 by 2. So we get x power 1 by 2, that is square root of x. After finding integrating factor, y into integrating factor, y into integrating factor is equals to q into integrating factor 3x square into x power 1 by 2 dx plus c. 3 is constant, base are same, add the powers, x power a into x power b is equals to x power a plus b. 2 plus 1 by 2, 5 by 2. Now use the formula integral of x power n plus 1, 5 by 2 plus 1 is 7 by 2 plus c. 6 by 7, x power 7 by 2 plus c. We get y is equals to 6 by 7 upon x by 2 plus c upon x by 2. 6 by 7, 7 by 2 minus 1 by 2, 6 by 2, that is 3, x cube plus c into x power minus half. Now the next one is question number 3. Write down the statement. Solve the differential equation x log of x dy upon dx, x log of x dy upon dx plus y is equals to 2 upon x log of x. 2 upon x log of x. What is the value of p here? First we have to make its coefficient 1. So we will divide the whole equation by x log of x. 1 upon x log of x into y. 2 x log of x divided by x log of x. So dy upon dx plus 1 upon x log of x into y is equals to 2 upon x square. From here p is equals to 1 upon x log of x, q is equals to 2 upon x square. Now integrating factor p dx, p is 1 by x log of x dx. Put log of x as t, we have the derivative of log x here. Derivative of log x is 1 by x, dx is equals to dt. So integrating factor is equals to e, 1 upon x dx is dt and log x is t. Integral of 1 upon t is log of t, so e power log of t, that is t. And what is the value of t here? Log of x. Now put the value y into integrating factor is equals to q into integrating factor dx plus c. 2 is constant, x power minus 2 log of x dx plus c. Log of x into y. Now we will use integral by parts here. By taking log x as first function, logarithmic function as first and algebraic function as second. Y into log of x, first function as it is, integral of second minus integral of derivative of first function into integral of second function plus c. 2 log of x, integral of x power minus 2, x power minus 2 plus 1 y log of x is equals to minus 2 log of x upon x minus 2 by x plus c. Take 2 by x common. Log of x plus 1 plus c. Y log of x is equals to minus 2 by x log of x plus 1 plus c. Now the next question is question number 4. Solve the differential equation x square minus 1 into dy upon dx plus 2xy is equals to 1 upon x square minus 1. Now first what we have to do, first make the coefficient of dy upon dx unity. So we divide this equation by x square minus 1, 2x upon x square minus 1 into y, 1 upon x square minus 1 whole square. Now by comparing it with the general equation, we get p as 2x upon x square minus 1 and q as 1 upon x square minus 1 whole square. Now in the next step we have to find the integrating factor. Integral of p dx 2x upon x square minus 1 dx. Now derivative of x square is 2x, derivative of 1 is 0. So this integral is of the form integral of f dash x upon f of x is equals to log of fx. And log will get cancelled, we get the integrating factor as x square minus 1. Now y into integrating factor, integral of q into integrating factor, 1 power will get cancelled, 1 upon x square minus 1 dx plus c. Now what is the formula for integral of 1 upon x square minus a square is equals to 1 upon 2a log of x minus a upon x plus a. So y into x square minus 1 is equals to 1 by 2 log of x minus 1 upon x plus 1 plus c. Now the next question is question number 5. Solve the differential equation dy upon dx plus sec of x into y is equals to tan of x. Dy upon dx plus sec of x into y is equals to tan x. Compare it with the general equation, we get p as sec of x and q as tan of x. Now in the next step we have to find the integrating factor. tan square is equals to sec square x minus 1. Now what is the integral of sec x tan x is equals to sec of x. Integral of sec square is tan x. Integral of 1 is x. Y into sec x plus tan x is equals to this. Now the next one is question number 6. Solve the differential equation cos square x dy upon dx plus y is equals to tan x plus y is equals to tan x. Now first, make the coefficient of dy upon dx unity divided by cos square x. 1 upon cos square x into y, tan x upon cos square x. 1 upon cos square is equals to sec square. So sec square x into y, sec square x, tan x. Now p is sec square x and q is sec square x, tan x. Now in the next step we will have to find integrating factor. Integral of sec square x is tan x. So we get the integrating factor as e power tan x. Now y into integrating factor is equals to sec square x tan x, q into integrating factor dx plus c. Now here we can put tan x as t. Put tan x as t. What is the derivative of tan x? Is sec square x. Y into e tan x is equals to, after differentiating we get sec square x dx as dt. Tan x is t into e power t dt plus t. We will solve this integral by using integration by parts, by taking algebraic as first function and exponential function as second. First function as it is integral of second minus integral of derivative of first, integral of second plus c. Integral of e power t is e power t. Derivative of t with respect to t is 1. Integral of et plus c. T into et minus e power t plus c. E power t minus 1. What is the value of t? T is tan of x. E power tan x minus 1 plus c. Y is into e power tan x. So we get y as tan x minus 1 plus c into e power minus tan of x. Now the next one is question number 7. Solve the differential equation x square plus 1 dy upon dx plus 2xy is equals to square root of x square plus 4. Again, to make the coefficient of dy upon dx unity, divide this equation by x square plus 1. We get dy upon dx plus 2x upon x square plus 1 into y is equals to square root of